One finding that was quite shocking and unexpected was that it was thought by many years of misconceptions that when you have a fingerprint that is exposed to direct sunlight, that fingerprint may degrade much faster because of the degradation of the sunlight, because of the UV light, or whatever they thought. So we ran not one, not two, not three, but several experiments exposing fingerprints directly to the sun, and they are better preserved than fingerprints that were stored in a closet or in a drawer or anywhere that was in the dark. And we have some theories why that may happen. Why a fingerprint that it's on, for example, let's say a window. Someone has broken into a house and we see a few fingerprints on the window of the side window of the house that is hanging out there. So we have a fingerprint. That fingerprint may stay there for years and years and years and years without being degraded ever. We think that it's because of the dehydration process that actually it mummifies the actual thing. The same thing that happens with mummies in Egypt. When we have those mummies, they have dehydrated the bodies and they're preserved for thousands of years. So we think that the oils get, I think the word is saponified, they get emulsified, like butter in a way, and they become, in a way, mummified. And that's why they can last much longer. That's one of the theories that we have. So this mummification process, and the fingerprint may be a year old, 2 years old, and it looks as fresh as yesterday. It's just because it had got frozen in time because we removed all the water content. However, when you have a fingerprint that's in complete darkness, in a closet or in a drawer, you have a lot of bacteria growing. Keep in mind that fingerprints have a lot of oils, they have a lot of water content or somewhat water content, and we also have microbiomes on the skin. Those microbiomes would also feed on those oils that you have deposited on a fingerprint. And
actually, fingerprints found at crime scenes, I would think that the perp would be much more likely to be sweating, alert, anxious, nervous, that kind of stuff. So I would think they would exude a lot more, into their fingerprints than someone that's calm. Have you ever had fingerprints taken from someone that was calm versus someone that was like really agitated or excited or had worked out?
Nope. Actually, we have not done that type of research. Usually but that would be actually one thing to research. It is expected that when you are committing a crime, of course, you're sweating much more, your heart is beating much faster. But we have ways to imitate that in the lab. So we have ways to recreate those conditions. For example, one of my first experiments, I went around the lab running for like 10 minutes. So I was sweating, my heart was beating super fast. And I know it's not exactly the same thing because I'm not stressed and certain hormones may not be showing, but we're trying to simulate those cases of like high, sweat versus someone who's very calm. And we saw differences. There are some differences. Actually, those type of fingerprints are high content, what we call it a green sweat. They tend to degrade much faster. So as opposed to what we call the sebaceous rich fingerprint, which are more like oily, those tend to be a little more sturdy over time. There are differences. This is a whole new world, and I suggest that if anyone is interested in this type of research, the book that I published, actually, it explains, quite a lot of what is known about fingerprint aging. It includes all the chemical analysis, visual analysis in 3D and 2D. So it's a very comprehensive book. So if any of your audience is interested in that book is already there available. So those conditions of the donor, we also take them into consideration when doing this type of analysis. We've done, for example, considerations on biological sex, with males versus females. We have done age studies. We have done, when it comes to donors, we have done BMI, the body in
mass index.
There you go, BMI. We have done, what else have we done? I don't know. We've done a lot of studies that also relate to the conditions of the donor. So, and everything has its own, I would say, particularities. So the more cases that we see, the better. But also at the same time, forensic science sometimes is not considered a proper science or a true science. And it's very difficult to actually get resources, financial resources for research. And that can be problematic sometimes because we have to run, very small experiments. There's a lot of competition as well between different labs, between different agencies. And it's difficult to have breakthroughs, like a very important breakthrough. It takes a long time. And it's just because there's not a lot of investment in conducting research in forensic science as compared to, for example, cancer research or any other sciences that, of course, they get a lot of attention for an obvious reason as well. But me as a researcher that I came from a molecular cancer research field, I can see there's a huge disparity between these pure biological sciences compared to forensic science. And it's difficult to have advancements, and it takes a long time to actually run experiments, to come to conclusions, because you have to dose the experiments because they're very expensive to run as well. So that's one of the downsides of trying to find answers to the research that we're trying to answer all those questions. And it's difficult to actually do the research.